Howdy, this is your friendly neighborhood physics teacher here to review you over friction. Now, friction is just a force. You do have an equation that goes with friction. Okay, so my thing decided to switch. So your force of friction equals your mu times your normal force. So let's break down each one of these. Now, your force of friction. Key thing to know about force of friction, it goes opposite of the motion. It goes opposite of the motion. Okay? Or opposite the force. Yeah, so opposite of the motion. Your mu, that is it's also known as your coefficient. I misspelled that. Friction. It's your coefficient of friction. Basically, what that is how the two surfaces interact with each other. You have like surface 1 and you have surface 2, and it's how the two surfaces interact. You have two smooth surfaces, you're going to have a very low coefficient of friction. If you have two rough surfaces, you're going to have a very high coefficient of friction. And then, of course, somewhere in between. Your coefficient of friction should never be greater than 1. So your number should always be less than 1. Your mu should always be less than 1. And then you have your force of normal. And you have two situations. If you have a flat surface, your force of normal is going to equal your force of gravity. If you're at an angled, your force of normal is going to equal your force of gravity in the y direction. And then if you have a force being pulled at an angle on a flat surface, your force of normal is going to equal your force of gravity minus force of gravity minus your force in the y. So those are kind of the three force of normals you could come up with. Now, so that's kind of the breakdown of the equation. And that's pretty much it. I mean, that's the logistics behind your force of friction. Your force of friction is opposite of the motion. Your coefficient of friction is how the two surfaces interact. And that's different for any surfaces. There's hundreds, thousands of millions coefficient of frictions out there. And then you have your force of normal, which if it's on a flat surface, it'll equal force of gravity. If you're on a tilted surface, it will equal your force of gravity in the y direction. And then, like I said, if you have a force being pulled at an angle, you have to take that into consideration, and you subtract that by your force of gravity. So we'll definitely do one of each one of these practice problems. And I'm talking about coefficient of friction. So we have a box on a surface. And if you're just given a word problem, I highly suggest you to actually draw out a free body diagram. It helps a lot. So the force that's always there is your force of gravity. Now, if you're on a flat surface, your force of normal will just go straight up. And let's say you're being pulled like a force applied, a force of pull, and therefore you have said force of friction. Now, in this practice problem, there's a couple of key things. it's moving. So a couple of key things. So it's at constant speed. Now, if hopefully you watched the net force review before you did this one, but if you remember, constant speed means that your net force is 0. So your constant speed means that your net force is 0. And when your net force is 0, that means your forces have to be balanced. So basically, what you're looking at is your force applied. Force applied is got to equal your force of friction. And your force of gravity has got to equal your force of normal. This is only true if you're at constant speed. So let's say in the problem, I say that your force applied is 20 newtons, and I've given you a mass. I've given you a mass of the block of 30 newtons. So you already know that your force of gravity is mass times the acceleration due to gravity. So gravity equals, and that would equal your force of normal. So it would be 30 times 9.8 equaling your force of normal. So you plug that into your calculator. You do 30 times 9.8, and you end up getting 294 equaling your force of normal. In this case, your force applied was 20, so therefore your force of friction is 20. And now you can use your force of friction equation. You have your force of friction equals your mu times your normal force. Plug in what you got. So your frictional force was 20. Your frictional force was 20 equals, you're looking for your mu times your normal force, which was 294. To get mu by itself, you just divide. And so your mu would be 20 divided by 294. That gets you 1.07. 1.07. Remember, always go 2 behind the decimal. 1.07. And there's no unit for coefficient of friction. No unit for coefficient of friction. So that's our answer. So it's a very small coefficient of friction. It's not bigger than 1. Yay! So that's if it's at a constant speed. Now let's look at one. Let's see, what was our 3? Okay. Now we're going to jump down to this third one. If it's being pulled. If it's being pulled at an angle. So we're going to go back to our box here. You still have your force of normal going up. You still have your force of gravity going down. But now your force is being pulled at an angle. So now your force is being pulled at an angle. Now when your force is being pulled at an angle, that's when you have to break it down into its x and y components. And the angle, let's just say it's 30 degrees. This is where your 90 is. So that's at 30 degrees. And don't forget about your force of friction. Force of friction. Now, if you notice, when I draw it, that's our force applied. The solid forces are your actual forces. The dotted line are your components. So this becomes your force applied in the x direction, and you have your force applied in the y direction. And just remember, think about like a graph. When you make a graph, when you do, this is your x-axis, this is your y-axis. That's what I mean by x and y. This is still moving at constant speed. So still moving at constant speed. So that still means that our net force is 0. So knowing that information, we know that our force applied in the x has to equal our force of friction. And the reason we know that is because they are the only two in the x direction. They're the only two in the x direction. So they're the only two in the x direction. And now, looking at it, we have 2 going up, so that means our force, a normal, plus our applied force in the y is going to equal our force of gravity, because we have 2 going up and 1 going down. So everything's, so everything going to the left it's got to equal everything going to the right. Everything going up has got to equal everything coming down. And that's just because it's moving at constant speed. Now, I need to give you a couple of givens. The mass, need a little bit more room, so that little squirrely is going to go our mass of the block, let's stick with just our givens up here so we can kind of see the difference. So our mass of the block was 30 newtons. Our force applied, 120 newtons. Yep. Force applied was 20 newtons, and we already have our angle. So we know we need to break our force applied into its x and y components. So we can look at it and figure out which ones are opposite, adjacent, and hypotenuse. The angled one's always your hypotenuse. This is your angle. So your F applied in the y direction is your opposite, and your x is your adjacent. So if we're doing our adjacent, we know that would be cosine of the angle equals your adjacent over hypotenuse. We know that our angle is 30. Our adjacent is force applied in the x, and our hypotenuse is 20. So you just multiply both sides by 20, and you get your force applied in the x to to be whatever the calculator is. Make sure you're in degrees. Make sure you're in degrees. I had a couple people tell me when they did the quiz they were completely in radians. So guess what? Make sure you're in degrees. What are you going to make sure? You're in degrees. Awesome. Thank you. So, and you get 17.32. Always go 2 behind the decimal. That is in newtons. And that also equals your force of friction because it's balanced. Now, looking at our information here, we know that the force of gravity is just mass times the acceleration due to gravity. And your applied, since it's opposite, would just be your sine. So sine theta is your opposite over hypotenuse. Your angle is 30. Opposite is force applied in the y. And your hypotenuse is just 20 again. Multiply both sides by 20. So they cancel out here. And you get your force applied in the y to equal your sine 20 sine 30. Again, just a reminder, it should already be in degrees, but make sure it's in degrees. So sine of 30 times 20. And you get 10. And 10 newtons. And your force of gravity was your mass, which the mass of the block was 30. So, do 30 times 9.8. 30 times 9.8, which we did above, would get us the 294 newtons. And then you can just plug it to your equation here. We don't know our force of normal. So what we need plus our force applied in the y is 10. And that equals our force of gravity, which is 294. So how do you get your force applied? How do you get your force of normal by itself? Yep. You subtract the 10 over. So you get that your force of normal equals 284 newtons. Now that we know our force of friction and we know our force of normal, we can just do our force of friction equals mu times normal force. We do 17.32 equals mu times 284. And you just divide by 284. That's a horrible mu. And you get 17.32 divided by 284. And you get about the same coefficient of friction. And you get about the same coefficient of friction. Okay, so now let's do one going on an incline. So, it's on an incline. Again, you have your force of gravity goes straight down. It's on an incline, so now your force of normal has to stay perpendicular to the surface. So your force of normal stays perpendicular, so now it's kind of like at an angle. And naturally, if you think about things going down a hill, naturally the object wants to move in this direction. So since it's moving in that direction, our force of friction would be in the opposite direction. That's kind of our free body diagram there. To make life easier, we rotate our frame of reference. So this becomes our y, this becomes our x. Again, the reason we do that is just to make our life easier. In that way, we have to break our force of gravity into its x and y components. And the theta here is the theta up here. That's like your opposite adjacent theorem, I believe. But you don't really need to know that. So that'd be your force of gravity in the y. You just need that angle and that angle are the same. And this is your force of gravity in the x. So if you're looking at your opposite, adjacent, all that fun stuff, this is always your hypotenuse. This becomes your opposite, and this becomes your adjacent. So a couple of givens you need to know. I'm going to give you your mass. So again, let's just stick with the same mass. Your mass, let's just say, what was it again? What was your mass? 30? Our mass is, 30 newtons. Our angle, let's say, is 30 degrees. And I need to give us our acceleration. Let's say our acceleration is 5 meters per second squared. And we're looking for our force of friction. So, again, we have to figure out what all our forces are. And then once we figure out what all our forces are, we can then begin to figure out our net force in the x and net force in the y. Now, since it is accelerating, nothing is balanced. You can't just set it equal to itself like we did up here, because it is accelerating. You do have acceleration, so therefore you do have a net force. It's an actual number. But let's just start solving out. So we can figure out our force of gravity. Force of gravity is just our mass times our acceleration due to gravity. Our mass is 30. Acceleration is 9.8. So that just gives us 294 newtons. So that is our force of gravity. So once we know our force of gravity, we can actually break up our force of gravity in the x and y, since it's a triangle. Our force of gravity in the x, to find that, since it's opposite, we're going to use sine theta, opposite over hypotenuse. So sine is 30. Our opposite is force of gravity in the x. Our hypotenuse is 294. Multiply that on the other side. And you get that your force of gravity in the x is, you need a calculator for that. Again, make sure you're in degrees. 9 times 294. And you get 147 newtons for that. And then to find your force of gravity in the y, you'll use cosine. Now, if you've already done the force, the net force review or the force table review, you notice that on all those it was cosine for your x and sine for your y, this is the only time it will flip is when you're dealing with gravity. So you don't necessarily have to memorize it. I would always just do your opposite over adjacent hypotenuse, label those, and you can go from there. The force of gravity in the y, hypotenuse, big number. We'll just multiply by both sides, and you get your force of gravity. So you do cosine of 30. Again, make sure you're in degrees. I feel like if I say it enough, you'll just start checking it in your sleep. Okay, so 254.61 newtons. So we figured out the force of gravity in the y, and we figured out the force of gravity in the x. Now, if you remember, the force of gravity in the y and the force of gravity in the x are equal. And that's because they're not moving. It's not moving in the y direction. The box is not coming off the angle. It's just going down. So it's moving in the x. It's not moving in the y. So they equal each other. So that's also our force of normal. So we have a force of gravity in the y, we have a force of normal, we have our force of gravity in the x, and we're looking for our force of friction. Now that's when our net force comes into play. So our net force, specifically in the x direction, equals our mass times acceleration. Now remember, net means you're catching all the forces in the x direction. What forces do we have in the x direction? What forces do we have in the x direction? We have our force of friction, and we have our force of gravity in the x. And they're going opposite from each other, so they'll end up being subtracted. Now make sure whatever sign you give them, that since force of gravity in the x and your acceleration are going in the same direction, make sure you give them the same sign. So the net force ends up being your force of gravity in the x minus your force of friction equals your mass times acceleration. We figured out your force of gravity in the x is 147 minus your force of friction equals your mass was, what did I give it, 30? Mass is 30, and your acceleration was 5. So, and then you just solve for your force of friction. So 30 times 5 gives you 150. You get force of friction by itself. You subtract this over. Oops. You get negative force of friction equals, that should be 3. But that's a be 3 newtons. And it's negative 3 because it's going in the negative direction. We made that positive, so that's negative. So your answer is 3 newtons. Again, remember in physics, negative just means direction. So those are the more complicated ones. I mean, if you're just trying to find your force of friction, and you're given your mu, just multiply your mu times your normal force. Yes, it's just that simple. Just multiply your mu times your normal force, and you'll get your force of friction. So that's all about friction. Know that it moves opposite of the motion. And a couple of these practice problems. And don't forget the really simple ones on your homework, like the first two. It's mu times normal force. It really is that simple. So I hope you have fun studying. Bye.